So we're looking at optimizing 1 over x over the interval from 0 to 3. Now we do have a closed interval, but notice what happens at 0. If we look at it graphically, we see at 0 this thing is discontinuous. So let's see if we can find the max and min graphically. Well, the fact that it's not continuous at x equals 0 is going to cause a problem because we no longer get the guarantee of the extreme value theorem. So we're going to take a closer look over at this part of the graph. And what we see is at 0, it just goes up and up because there's a vertical asymptote there. So it's going to have no absolute maximum value. That does not mean there won't be a minimum. Now remember, we're on 0 to 3. This function is always decreasing. It's nice and continuous at 3. So we're going to throw in a point right there, and that's going to be our absolute minimum because that's the lowest the graph can achieve on 0 to 3. So we lose the guarantee of the extreme value theorem, but it doesn't mean there's no extreme values. Now this point here, well, the input is 3, and the output then is 1/3. So this is the point 3, 1/3. So we had no absolute maximum on this interval for this function. The absolute minimum happened, and it did occur at an endpoint. There were no critical points in between 0 and 3. The absolute maximum value is 1/3. It occurred at x equals 3, so make sure you pay attention to the difference between those two. Now, if we switch our interval to be from 0 to infinity, well, we still have no absolute maximum because we had this vertical asymptote. Now the graph is going to decrease, and it's going to just keep decreasing. So it turns out we have no absolute minimum either. So once we lose the guarantee of the extreme value theorem, as you see, we need to do a little bit of extra work by looking at the graph of the function, by exploring the critical values and seeing what's going on at the endpoints.